Okay, we're continuing on this series of videos on proofs. As a reminder, for proofs, write out every single step in words and in math notation. Whenever you have to prove that something equals something else, don't ever work across this equal sign. Don't add or subtract or divide. Think of it as this is your problem and this is your answer. And then here were some of the hints we talked about last time. Let's simplify things by distributing and combining like terms, or if you have fractions, you may want to factor and cancel things. It also helps to convert everything to sines and cosines because we know how to convert everything to sines and cosines, and that will help you with this next new hint, look for identities. All of our identities are going to be written in terms of sines and cosines. So if you have it converted and written as sines and cosines, it'll help you identify your identities. It'll help you notice them. Okay, here are your identities in case you don't remember. This is the tangent identity, your reciprocal identities, and more specifically today we're using the Pythagorean identity in all of these examples. You only need to know the first one, the one with sines and cosines, but if you know the other two, that's great. You may not need to convert everything to sines and cosines then to be able to recognize that. Okay, we're going to do 3 examples. So example number 3, this is the third one from last time. We're going to prove that sine theta plus cosine theta times sine theta plus cosine theta simplifies to 2 times sine theta times cosine theta plus 1. So if you think back on your hints, you have a couple of options here. I would not convert everything to sines and cosines because it's already in terms of sines and cosines. And right now I don't see any identities yet. So our only option here is to simplify. So let's distribute this first thing. I hate parentheses, so let's get rid of them. So what is this called? Distribute. Remember, write out your steps. So sine times sine is sine squared theta. Sine theta times cosine theta is sine theta cosine theta. Cosine times sine, you can write it as cosine theta sine theta, or you can write it as sine theta cosine theta. And then cosine times cosine is cosine squared theta. Side note, you should be thinking ahead of every single step, so that way you're getting better at proofs if you can do this on your own. And then also, the reason I wrote it like this instead of cosine theta times sine theta is because order doesn't matter when you're multiplying things together. Think, 2 times 3 is going to give you 6, and 3 times 2 is also 6. So order doesn't matter as long as it's just these two things multiplied together. The reason I wrote it as my sines first, and it might be helpful for you to always put your sines before your cosines no matter what you're doing, is because now that'll help me. This is the first time so far that we've actually had like terms. Both of these have a sine and a cosine in them. Nothing's extra squared, nothing else is going on. So I finally have like terms. So next step, combine like terms, or you can say add. So these two are like terms. I can add them together. 1 sine cosine plus 1 sine cosine tells me I have a total of 2 sine cosines. And I still have my sine squared theta at the beginning and my cosine squared theta at the end. So if you're looking ahead at your answer key, this is good because we have our 2 sine cosine theta. If only there was some way to make this into a 1. So these two pieces into a 1. You are going to be so tired of this Pythagorean identity by the end of this section. Sine squared plus cosine squared equals 1. Anytime you see a sine squared, a cosine squared, or a 1, just kind of see if there's a way for you to rearrange that Pythagorean identity to get what you want. So sine squared plus cosine squared is 1. So Pythagorean identity, I can replace this sine squared cosine squared with a 1. And now I got everything I need, so I'm done. Beautiful. I said that always look for a sine squared and a cosine squared and a 1 and see if there's any way for you to rearrange the Pythagorean identity to get what you want. You're not necessarily going to be given a sine squared plus a cosine squared. You could have 1 minus cosine squared. and try and use your Pythagorean identity to rearrange and get what you need. You can rearrange any identity. You can actually work across the equal sign for identities. So what I mean is, if I wanted to move this cosine squared to the other side of the equal sign, I would just subtract it like it was a normal problem. So look, now it's no longer on the left-hand side. I just have a sine squared over there. And on the right-hand side of my equal sign, I now have a 1 and a minus cosine squared. So if you see 1 minus cosine squared in any problem, you can just replace it with a sine squared. That's your rearranged Pythagorean identity. You don't have to move the cosine, you can move the sine instead. So if I wanted to subtract it to the other side of the equal sign, now it's no longer over here on the left, and so I'm just left with a cosine squared theta, and on the right-hand side I have a 1 minus sine squared theta. So if you see a 1 minus sine squared theta in any proof, you can replace it with a cosine squared. You don't have to show these steps. You can do this rearranging in your head, but your step that you would write here is that you used the rearranged Pythagorean identity. Okay, take a minute to see if you can rearrange the Pythagorean identity to get these two answers here. And you pause the video if you need to. You should end up with a negative sine squared theta for the first one, and then for the second one, it should be a sine squared theta minus 1. If you need, or if you have questions, email me. So that's important because we're going to use the rearranged Pythagorean identity on this next example. So show that sine theta tan theta times cosine theta minus cosecant theta times cotangent theta, all of that, equals or simplifies to negative cosine squared theta. You should be thinking ahead on every single thing I do, but I'm not going to pause for you to do that in these videos. So first thing I'm going to do is use our hints from before, simplify by distributing and combining like terms, because I don't like parentheses. So distribute. Unlike last time, there's not a plus sign between here, so I'm going to take this whole piece, sine and tangent, together and distribute it to the two pieces here. So I'll have a sine theta, tan theta, cosine theta, minus a sine theta, tan theta, cosecant theta, cotan theta. I don't have any like terms. This one has 3 pieces, this one has 4, so clearly those aren't the same. So that hint's done. But if I look at my second hint, I can convert everything to sines and cosines because right now I have a lot going on. I have 1, 2, 3, 4, 5 different trig functions. So if I convert to sines and cosines, I'll only have 2, so it makes it easier. I shouldn't be talking right. It makes it easier to simplify things and also easier to recognize identities. So if I convert this to sines and cosines, my sine just stays as sine. You can write it over 1 if you want. Tangent's going to now be sine theta over cosine theta. Cosine stays like it is. I can write it over 1. For my second piece, sine theta can be written over 1. Tan theta is sine over cosine theta. Cosecant is 1 over sine theta. And cotangent is cosine theta over sine theta. Now, I can simplify each of these fractions as long as you just look at these two fractions, like this fraction versus this fraction. Don't try and do anything across this plus or minus sign, or subtraction specifically here. So, if you look at this fraction here, can you simplify anything that's in the top and in the bottom? Because they're all multiplied, not added. So I can take away these two cosines, I can cancel this, and I'm left with just those two sines on top. So I'll have sine squared on top over 1, but you don't have to write that. For your second one, if you look at these, this sign on top will cancel with one of the signs on the bottom. I have a second sign on top that'll cancel with a second sign on the bottom, and then my cosines will cancel because one's on top and one's on bottom. I'm left with these 1s, or remember, if everything cancels out, just use a 1 as a placeholder. And then now, anytime you see a sine squared, a cosine squared, or a 1, see if there's any way for you to rearrange your Pythagorean identity. sometimes it's going to work and sometimes it's not, or sometimes it's going to be a double angle identity, I think, or sum and difference. One of the ones that we're going to do in a little while, not in this video. I think it's video 4. But if you look back to the problem we just did, can you rearrange the Pythagorean identity? We did. Negative cosine squared is sine squared minus 1. When you rearrange things, subtract your 1 to the other side, subtract your cosine to the other side. So notice I have a sine squared minus 1, so I can replace it with a negative cosine squared theta, which happens to be what I'm trying to get to. So I'm done. Try this one on your own if you want another thing to practice, but it'll use similar steps to this last example.